Hey, Sonny,
Hey, man.
you can't start fireworks in the state of Colorado.
Why?
Maybe if you understood the chemistry, you'd understand.
My name is Silicon Sunny,
I'm Fluorine Flo.
And I'm Germanium George.
and we're here to talk to you about fireworks.
Fireworks!
Fireworks.
Fireworks were invented about 1,000 years ago by a monk in China named Li Tan. Li Tan was keeping his gunpowder inside of a bamboo stick, and accidentally it slipped into the fire. This created a huge explosion, and essentially started modern-day fireworks. Nothing's really changed since then. We always have essentially gunpowder or flash powder wrapped around in paper and then a fuse. So what do we use fireworks for? Well, you guys know, things like fireworks shows at Disneyland or the 4th of July. And the way fireworks essentially work is that you have a metal and then you have an oxidizer, something like charcoal and potassium nitrate. So what these two are doing is they're interacting, in which the potassium nitrate, the oxidizer, will release oxygen, which combines with the carbon atoms in charcoal. This will create and release nitrogen gas, which expands the paper and then creating the big boom, the explosion.
That's pretty interesting, Sonny. But what's really cool is how the fireworks get up into the sky. Fireworks are actually really simple devices. It all starts with the mortar. This is a small case that points the firework into the sky. Each mortar is covered with a paper cap to keep the fireworks protected. The mortar is drawn in black. In each mortar is a cardboard disc, which holds the explosive in place. The cardboard disc is drawn in green. The explosive in the cardboard disc is called the aerial shell. The shell is the part that explodes in the air. This is drawn in blue. When a fuse is lit, it eventually reaches the base of the aerial shell. In the shell, some gunpowder is exploded by a fuse, pushing the aerial shell into the sky. This gunpowder is called the lift charge. Connected to the lift charge is another fuse, but this one is times. It is long enough that the flame doesn't reach the end until the firework is high in the air. At the other end of the fuse is some more gunpowder. This gunpowder then ignites, exploding into a bunch of stars that surround the gunpowder. These stars are what make the points of light in the firework.
The color we see in a firework display results from two phenomena, incandescence and luminescence. Like Germanium George mentioned earlier, the stars in fireworks are clay spheres filled with metal salts. During the explosion, the metal salts heat up and turn yellow or red, depending on the heat. This is called incandescence. This is like when you turn on the stove and the coils heat up and turn red. The other colors we see, such as blue, green, and purple, result from luminescence. The metal's outer electrons absorb energy from the explosion, which excites the electrons to a higher energy orbital. This excited state is unstable and therefore cannot be sustained. The electron relaxes back down to its ground state. Since the energy must be conserved, it is released as light, which we perceive as color. Lithium and strontium salts give red. Calcium salts give orange. Sodium salts give yellow. Barium salts give green. Copper salts give blue. Strontium and copper mixtures give purple. And aluminum, titanium, and magnesium salts give silver.
Silicon Sonny, it's a lot more fun when you understand the chemistry of fireworks.
Thanks, Germanium George.